All right, so our next unit is conic sections. So conic sections are named because they're literally sections of a cone. They're cross sections of a cone. So parabola is this cross section right here. An ellipse is that sort of squished circle. It's kind of like an oval. And then a circle is this cross section. And then the hyperbola is actually, it's sort of two pieces. It's when you take a cross section of two cones that are stacked tip to tip. So the hyperbola is actually this curve combined with this curve. So it's both of those pieces make up the hyperbola. So the first one we're going to look at for this week is parabola. So let's take a look at just sort of your basic parabola, right? You've got this y equals ax squared. So right now I have a set to be 1. So this is your most basic parabola. This is essentially y equals x squared right now because a is 1. So I'm going to look at what happens when we change the value of a, because there's really three things that are going to affect the shape of the parabola and where it's located. And one of those things is this value of a out here. So as a gets bigger, what you'll notice is that the parabola gets narrower and narrower, sort of steeper and steeper. And then as a gets closer and back to 0, it gets wider. And then it becomes, when a is negative, it starts to open down in the other direction. But again, as a gets sort of larger, and larger I mean more further from 0, the parabola gets narrower. So one thing to make note of is that if a is negative, the parabola opens down. It looks sort of like a frowny face. And if a is positive, then the parabola opens up. So it's sort of more of a smiley face. So that's one thing that will change. Okay, so the other thing that you can do is you can shift the graph left, right, up, down. So the first we're going to look at is a vertical shift. So right now, this function, we've just taken this one and just added a constant to it. So what this is, the effect that this is going to have as I change the value of k, which is currently 0. So if I increase k, you'll see that that graph is now just shifting up and down. So it's just taking that basic graph of y equals x squared and shifting it up and down. So that one's pretty intuitive, right? If I add a constant, it shifts it up, and if I subtract a constant, it shifts it down. And then what I want to look at here is, okay, what if I add something to the x value? So it shouldn't be too surprising that adding something to the x value shifts the graph left or right. What may turn out to be surprising, though, is the direction that it shifts. So I'm going to go ahead and change the value of h right now. So I'm going to start h, if I set h to be 0, we're right in the same graph. And then if I add something, if I make h positive, it actually shifts the graph to the left, which just seems somewhat counterintuitive. It feels like if I add something to x, it should shift to the right. But it actually works the opposite of what you would expect. And then if I add a negative, in other words, if I subtract something, it shifts the graph to the left. So here's what we're going to do. To compensate for the fact that this acts the opposite of what we want it to do, or what we expect it to do, we're actually going to make this a minus. So what that's going to do then is as h gets bigger, so if h is positive 4 or positive 4.2, that shifts the graph to the right so that it does what we think it's exactly what we think it's going to do. So what I've done down here is I've turned on this vertex right here. I've labeled it hk. So what you'll notice is the coordinates of the vertex, the turning point of this parabola, actually match the values h and k in this equation, and that's going to be key to being able to write equations. If we give you, if you know what the vertex is, you're going to use that to help you write the equation, and then you're going to use this to get, you're going to use the y-intercept to figure out what a is. But knowing that these values get you the vertex of your parabola is going to be key to writing the equations.